Conditional probability is what we are going to cover in this lesson, but please don't forget to subscribe to the channel. Now, conditional probability is when we have something occurring after some event has occurred already. So for example, if you consider events A and B, the probability that probability of A and B given B is denoted by probability of A stroke B. This is what we say. Probability of A given B. Now, this is how you write it. And whenever you have probability of A given B, it's the same as the intersection of these two things over the probability of this one here. So, probability of A intersection B is the same as probability of B intersection A. But probability of A given B is not the same as probability of probability of B given A. These are not the same, they are not equal, but these are the same. Let us see some examples. Events A and B are such that probability of A is that B, then the intersection is this. Find probability of A, this will that is given B. So, you summarize the question like that. Then if you come to part A, probability of A given event B. So if you have A given B, it's the same as probability of A intersection B, the whole over probability of B. You have everything there. This is 0.3 over probability of B, which is 0.4. And then press your calculator. A given B is going to be get 0.3 divided by 0.4, here I'm getting 0.75. That would be the answer. And come to part B, you want us to get probability of B given A. This will be the same as probability of B intersection A over probability of A. But we say this is the same as probability of A intersection B. Probability of A intersection B over probability of A. So this will be probability of this was 0.3, probability of A was 0.5, and this one is going to give you 0.6. And this sum probability of B given A is that. I think this one they are both the same. So orange, don't confuse with that. Now, sometimes they will tell you that they will just give you probability of A, then they give you probability of B, and they tell you if A and B are independent events, find probability of A given B. We say if they are independent, to get the intersection, you multiply probability of A intersection B is the same as probability of A and probability of B. So if they say that they are independent, they want to give you this because indirectly they would have given you these two. So if they say independent, you just get this, and this will be the probability of the intersection. Then you can handle it. Like, so I'm not going to do that example because we have seen independent events. Let us see this one here. If probability of R is this, probability of S is that, and probability of R given S is this, find probability of R intersection S. So in our solution, we start with the basics we have. We have probability of R as 0.5, probability of S as 0.35, and probability of R given S as 0.6. So now they are asking us to get in our part A probability of R intersection S. But what do we have from the base? We know that our probability from here, our probability, so you can say that probability of R intersection S, given S, the same as probability of R intersection S over probability of S. So we have this, we need this, as simple as that. So you can easily cross multiply there. So now, by cross multiply there, start now from here. Now my probability of R given S will be, okay, now that's the case. Then because I have it already there, so allow me to just cross multiply. So it will be cross multiply times probability of S equal to probability intersection S. So they gave us this and this. So we need this. We just cross multiply there. So this was given as 0.6 times probability of S, 0.35 equal probability of R intersection S. So press that on the calculator. Here I'm getting 0.21 B to R intersection S. So when they give you something, always learn how to be flexible. What do I have? What do I need? What? How can I get it? The probability, then right I mean part B, one probability of R given S complement. How do we have this? We know how to calculate this. This will be probability of R intersection S complement over probability of S complement. And now, this one we have to use the continuous table. If they were independent, we would have done that with this direct. But now, they are not independent. How do we handle this? Handle this, now we are going to use the continuous table. Of course, we say, hope you remember the continuous table. We have R, we have the R prime. We have S, then S prime. What do we need? We need R and S prime. R and, sorry, this is S prime. S prime. So R intersection S prime. So here we shall be having R intersection S. So now, you see that this is what we're going to use. We need this. We need this. We have this and this. So from here, I see that probability. But do that. Probability of R. From here, I see that probability of R will be probability of R intersection S plus probability of R intersection S complement. So I need this, so I can get this by subtracting. So from my P, now R, now minus. From here, when I subtract this, because I need this is what I need. Probability of R intersection S. The whole over. How do you get this? The same as 1 minus probability of S, because we have a complement. How are you getting that? Probability of S. Probability of S complement is 1. If you want this, you make it the subject. So probability of S complement will be 1 minus probability of S. So there is a matter of substituting. Probability of R is 0.5. Probability of the intersection 0.21 over, this is going to be 1 minus probability of S, which is 0.35. This will be, when we subtract that, it will be 29. I think this one is going to be 0.29, is it? Over 0.65. So what do we get there? So the answer I'm getting, give it 4 decimal places, 0.4462. I'm giving it 4 decimal places. And that will be my answer. So probability of R given its complement, that will be the answer. So members, that's how you handle conditional probability. I will see you when.